Now we're going to look at doing normal probabilities. And for all of these problems, we're going to use the StatCrunch normal calculator. But first of all, we have z, that's a random variable with the standard normal distribution. The first thing you need to look at with these is that anytime that you have a z for a variable instead of an x, that automatically means that it's a standard normal distribution. This means that your mean is 0 and your standard deviation is 1. To find this probability, we're going to go to the StatCrunch calculator. To get to the StatCrunch normal calculator, I opened a blank data editor, and then I used Stat, Calculators, Normal. Since this is a z, I'm going to leave my mean as 0 and my standard deviation as 1. I want to put in this inequality, and for the normal distribution, it doesn't matter whether it's a less than or equal to. And if you look at this, you only have two choices for inequalities. We want to make that a less than, and we're putting in our value here, which is negative 2.7, and that's going to give us our probability. I'm going to round this to 4 decimal places. So in this problem, we had the value for z, and it was asking for the probability. In the next one, we want to find the value of z so that the area to the right of that value is 0.37. This time they're giving us the area, or the probability, and we're supposed to go back and find the z. That means that we're going to use our StatCrunch normal calculator going backwards. We're going to put the value that we're given, the 0.37, in this box to the right of the equals sign. We also need to make sure that our inequality is pointing the right way. If we want the area to the right, that means that we have to change this inequality so that it points to the right. Then we're going to put our area or probability in the box to the right of the equals sign. The value that we get in this box is our z value. Usually with z values we round those to only 2 decimal places, but that would depend on the directions in the problem that you're doing. And it's a good idea to check with these and make sure that the shading is going the correct direction. In this one we wanted the area to the right, and it's the area in the right end of the graph that's being shaded. For this problem, we've got a normal distribution with a mean of 16 and a standard deviation of 3.4. This is asking us to sketch and label the normal distribution. To do our sketch, we're just going to draw in a bell-shaped curve, and the idea of this is that the mean is going to go in the middle. This would be the mean, which would be 16 feet, and we could label some points along here. We could go up or down a certain number of standard deviations. Our standard deviation is 3.4, so for example, if we went up by 1 standard deviation, that value would be 19.4. If we went down by 1 standard deviation, that would be 16 minus 3.4, which would be 12.6. So we could go ahead and label the rest of these points if we wanted to. Now the first problem that we're doing asks what percentage of pine trees in the park are taller than 22 feet. This is giving us the height of a tree. If we want to put that on our graph over here, that would be somewhere in there. And we want to know what percentage are taller than that. Taller means the height is bigger. So that means that we're trying to find the probability or the area in this right tail. And when they ask for a percentage, what we're going to do is find the area or the probability and then multiply that by 100 to get the percentage. So now we're going to use our normal calculator in StatCrunch. And this time, since we drew the sketch already, we want to make sure that what we come up with ends up looking like that sketch. One thing we're going to have to do is change the mean to 16 and the standard deviation to 3.4. And then we want x to be greater than or equal to 22. We want the inequality to point to the right because what we were doing here was going to the right. So now we've got this picture which matches what we had here, and we have our area or probability in this box. To get from the area to a percentage, we're just going to multiply this by 100. Depending on how much we're supposed to round this, we could leave it as 3.88%, or we could round it more than that. For the next question, we want to know the probability that a pine tree in the park is between 10 and 15 feet tall. So for this one, we have the same picture of our normal distribution. We have the 16 in the middle, and we've figured out a couple of these values. And we want to know the probability that the tree is between 10 and 15 feet tall. So that's going to be somewhere between, say, here and here. What our shading should look like is between those two values. If we go back to StatCrunch, because we're doing this between two values, we want to use the between function here. We're leaving our mean and standard deviation like they were, and we're putting 10 and 15 into these two boxes. And there's our probability. For the next part of this question, we want to know the cutoff height for the tallest 10% of the pine trees. So in this one, they're giving us a percentage. Remember, if they give you a percentage, that's really the same as a probability or an area. You just need to change it to a decimal. So 10% changed to a decimal would be 0.10, and that means that that is our probability or our area. If we go back to our picture, if we want the cutoff height for the tallest 10%, that means we want to know the height so that anything taller than that is in the top 10%. So we want to know what this height is right here in order for this area to be equal to 0.10. What that means in StatCrunch is that we're going to use the normal calculator going backwards. We also have to go back to the standard window because we're not doing this between two values anymore. Since this is going to the right, we want to make sure our inequality is going to the right, and we're using this backwards, so we're going to put the 0.10 into this box, and the answer we get here will be the height that we're looking for. Let's round this to one decimal place so we have 20.4 feet. In other words, if a tree is 20.4 feet or taller, then it's in the tallest 10% of the trees in the forest. The 20.4 is the value right here. For the last part of this problem, now we have a random sample of 40 pine trees instead of just one, and we want the probability that the sample mean height is less than 14.3 feet. This has changed our type of question because we're not just talking about one pine tree, we're talking about 40, and we're also talking about the probability that involves the sample mean. How we would write this in notation, our sample mean, instead of just being x, our sample mean is x bar. We want the probability that x bar is less than or equal to 14.3. What's different in this one is that we have a sample of 40 pine trees instead of just one, and that we're trying to find the probability that has to do with the sample mean instead of the probability about just a single pine tree. What that means is that we're going to have to use a formula to find our new standard deviation for this distribution. What we're talking about is the distribution of sample means. For that distribution, the mean is the same as the original mean for our pine trees, and that was 16. But for our standard deviation, here's where we have to use a formula. For that, we take the original standard deviation and divide by the square root of the sample size. Our original standard deviation for this was 3.4. Our sample size is 40 because we have a random sample of 40 pine trees. So we're dividing that by the square root of 40. That means our new standard deviation is 0.5376. To find this probability, I'm going to go back to my StatCrunch normal calculator. I'm going to leave in the mean that I had before, the 16, but I'm going to put in this new standard deviation. I'm leaving my mean as 16 and changing my standard deviation to 0.5376. And what I'm trying to find is the probability that my sample mean is less than or equal to 14.3. That means I want to change this to a less than or equal to, put in the 14.3, and there's my probability. If I round this to 4 decimal places, I have 0.0008. Now we're going to talk about how to find critical values, and this is for 3 different distributions that we might need critical values for. But for the ones from the standard normal distribution, these ones are always the same for the same confidence level. These ones don't change with the sample size. What I would do if I were you is to go ahead and have these 3 specific values written down when you get ready to take your exam. Because for 90%, the critical value is always this one. For 95%, it's always 1.96. For 95%, it's always this one. That way, when you're taking your test, you don't have to go back and try to calculate these values. Now let's say we're trying to find a critical value for a little bit different confidence level. It's very important in these to look at what the variable is here. If this is a z, that means that we're talking about the standard normal distribution. And that means in StatCrunch, we're going to use the normal calculator with a mean of 0 and a standard deviation of 1. And to do this, I want to use the between window in my normal calculator. So I'm going to change this to between. I'm going to put in my mean of 0 and my standard deviation of 1. And now, what I'm going to really do is use this tool backwards. So in this box to the right of the equal sign, I want to put in the decimal value of my confidence level. 93% is the same as 0.93. So that's the number that I'm going to put in to the right of my equal sign here. And it's going to give me 2 different values. The one I want is the positive value. I should just have the negative and the positive of the same number. So my critical value is actually just the positive one of those 2. And how much you round these depends on the question. Now let's look at what we would do for a critical value if we have a t here. That means that we're using a different distribution. So this is the t distribution. That means in StatCrunch, we're going to use the t calculator. In StatCrunch, I'm doing stat calculators and t. This is very similar to what we did with the last problem. We want to use the between window. For this, we don't put in the mean and the standard deviation, but we have to put in the degrees of freedom, which is the df right here. The df is the sample size minus 1, which for this one, our sample size was 37. That's going to be 37 minus 1, or 36. Putting in 36 here. And again, we're using this tool backwards. In this box over here, I want to put in the decimal value of my confidence level, which would be 0.90. That gives me my critical value of 1.69 if I'm rounding it to 2 decimal places. Next, we're going to look at critical values for the chi-square distribution. For this one, you actually get 2 different values, but it's again the same idea. We want to take the decimal value of our confidence level. In this case, it would be 0.99. We're going to have to know the degrees of freedom. That's going to be our sample size minus 1. In StatCrunch, I'm going to use stat calculators and chi-square. I'm using the between window again. I'm putting in my degrees of freedom, which we said was 24. I'm using this tool backwards also, so here I'm putting in the decimal value of my confidence level. In this one, I get 2 very different numbers. So for chi-squared, I get 2 different critical values instead of just 1 like I got for the other distributions. So here my 2 critical values are 9.8862 and 45.5585.